Question 2. So the discriminant b squared minus 4ac is an A-level concept, but it's part of the larger quadratic formula, isn't it? So quadratic formula being x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And it's important because if this was a negative value, you can't have a negative square root, so you won't get any answers. There will be no solutions. So anyway, we have got our b is negative k plus 8, that is our b, and our c is 8k plus 1. So b squared will be negative k plus 8 all squared. But when you square all of that, the negative's just going to disappear, isn't it? Minus 4 times, then you've got your 8k plus 1 for your c, and I haven't bothered putting the times 1 in there because that's just your a is 1 because there's only 1x squared. So if you do k plus 8 expanded, that gives you k squared plus 16k plus 64, and then you're going to be taking away, and I'd leave this all in a bracket for now, 4 times 8 is 32k, and 4 times 1 is 4. Then you've got to consider, if you're taking all of this away, you're taking positives away both times. You're actually going to take that away and take that away. So it's going to give you k squared. When you take 32 from 16, you get negative 16k. And when you take 4 from 64, you get plus 60. So that is your final answer there. Part B, if the original function has 2 equal roots, otherwise you think of that as one root really, it means the turning point is just touching it once. Find the possible values of k, and the discriminant is always equal to 0 when you've just got the one point that it's happening at, or the 2 equal roots. So we're saying k squared minus 16k plus 60 equals 0. So then we just need to factorize. 10 times 6 is 60, and 10 add 6 is 16, so it'll be k minus 10, k minus 6 equals 0. Our values that make the brackets equal 0 are our solutions, so k equals 10 and k equals 6. Show that when k equals 8, the function x is bigger than 0 for all values of x. So first of all, we're taking this and we're just going to substitute 8 into there. So our function x is going to be equal to x squared minus 8 plus 8x plus 8 times 8 plus 1. All of that is going to give us 8 plus 8 is 16, so that's going to be minus 16x. 8 times 8 is 64, plus 1 is 65. Now, in order for this to be bigger than 0 for all values of x, we need to show it's a positive quadratic, isn't it? And you are allowed to use a picture, although they don't really need it. But if you just think about it, we're going to be having that. What it's saying is that is not going to hit our x-axis. We need, the best thing to do is to find the turning point. You could do stuff with the discriminant to show that if the discriminant comes out as negative, then it must be so, but you then have to do quite a lot of explaining for why that's going to get you the answers. But so you are completing the square. So pop our little square bracket round here, then take it one bit at a time because it's so easy to make mistakes. We're halving our 16, and we're then going to take that squared away. So 8 squared is 64, and then we've got the plus 65. Then finally, remove the brackets. X minus 8 squared, negative 64 plus 65 is plus 1. And then, just running out of the room here, since you need to say something to show that we know that a square number is always going to be positive. So since x minus 8 squared is greater than or equal to 0 for all values of x, x minus squared plus 1 is greater than or equal to 1. And that should be enough. But you need some kind of a statement in there to make it so. Or, and you can, they would accept you, instead of that statement, showing your sketch and showing that that point there is going to be 8, 1, and then just something to sort of point out the fact that all of your values are going to be what's on the curve.